We're going to talk about areas of regular polygons. And this formula, this one you probably haven't seen before. Okay, this is H dash for areas of regular polygons. So say I have something that looks like, let's get a regular polygon. This thing lets me make different regular polygons, I hope. So let's start with usually they don't talk about it squared. So let's pretend that this is regular, okay? Meaning all the sides and all the angles are the same, okay? And I want to find the area of that. One thing I could do is find the middle, okay? And then I can draw in some triangles from the middle. Like that, okay? How could I find the area of that thing? Just in general, if you knew some stuff, how could I find the area of that shape? Find the area of each triangle. What would I need to know in order to find the area of each triangle? The base, yeah. So this is the radius, but you don't really need to know the radius. What you need to know is this thing right here that goes from here to here, right? The perpendicular, or the height of one of those triangles. This isn't coming out exactly perfect, okay? But if I knew this, right, I can say I know that this is 8, and this is, say, 6, okay? Then how could I find the area of that pentagon, regular pentagon, if all these sides and angles are the same? How could I do that? Right? I'd have base times height, 8 times 6, divided by 2. Right? That's the area of one triangle. And then I'd have 5 of those. Yes? Okay, so that would be 24 times 5. What's that, 120? 120 square units, whatever they are. Square units. Is that 120? 24 divided by 2. Okay? So another way to write this, if I call this thing has a name, right? This piece right here, this height in a regular polygon is called an apothem. I don't know why it's called that, it just is. Okay? So an apothem kind of is it's not the same as a radius, right? Because the radius goes to one of the vertices, so that apothem goes perpendicular to one of the sides. So another way to think about that, okay, I'm going to call this S, which is the length of the side from here to here, okay? And so a formula you could use is S times A times S. A times S, right, where they abbreviate this A. A times S divided by 2 times what? How many what's it has? Times the number of sides. ASN, okay, equals the area. Where A is the apothem, S is the side length, okay, side length, and N is the number of sides. So if I know this, right, that would be S, right? That would be S. N would be 5 in this case. I kind of switched around and A would be 6. Yes? No? We're good? So another way to write this formula, what do I get if I multiply S times N? If I know the side length times the number of sides, what do I get? What's that called? That's called the perimeter, right? So I could write an equivalent formula, okay? I could write an equivalent formula that says the area of a regular polygon is equal to either, the way they have it on your sheet, I think, is 1/2 ASN, right? Is that what I have on the back side? 1/2 ASN? ANS. ASN, ANS, doesn't matter. Which is equal to 1/2 A times P, where P is the perimeter, or the apothem times the perimeter divided by 2. So if you know the perimeter, you don't have to know the number of sides and anything. Get that? Maybe? Yeah. So I have one more example in here, and then we're going to do some practice. Let's just look at one more. If you have a regular hexagon, we will learn for regular hexagon, if I draw in all the triangles in a regular hexagon, only in a regular hexagon, these triangles all come out to be what type of triangles? Not isosceles. They all come out to be equilateral triangles. Who can tell me why they all come out to be equilateral triangles? How many degrees in a circle? 360. So what does each one of these have to be? Each one of them has to be 60 degrees, right? And if that's 60, right, then these two, because those two have to add up to 120, have to be 60 as well, right? So that's why these ones. So that's why only in a regular hexagon do those come out to be equilateral triangles. Hold on, I gotta give this student something. I'll be right back. Am I recording? I think I'm recording. The only thing that you have to know is, well, there's a couple things that you have to know. But with any regular polygon, a lot of times this apothem doesn't come out to be a nice even number. A lot of times it has decimals, right? Because if say this side is 8, right? Then you guys know the Pythagorean theorem, right? You know that we will learn more about it in chapter 9, which is the next chapter. But if this is 8, what would this piece have to be? What would this triangle, if this is a right triangle, what would this have to be? 4, right? And if this is an equilateral triangle, say this is, that would have to be 8 too, right? And then if you did the Pythagorean theorem, we're kind of getting ahead of ourselves here. You won't have to do the Pythagorean theorem on your homework, but I could go 4 squared plus a squared equals 8 squared. Yes? Right, you know that from Pythagorean theorem? And then 16 plus a squared equals 64. So a squared equals 48. So a is equal to the square root of 48, which is just slightly under what number? It's like 6.9 something, right? So it doesn't come out to be a nice even number because a triangle has to be, it has to meet certain. If this is a given length and this is a given length, then there's only one triangle you can make. So a lot of times for this apothem length, it'll end up being a decimal number, or they'll give you some weird number for that. And you go, why can't they just give you even numbers? Because the triangles wouldn't make sense if it were just a normal triangle. Okay, so let's go back. I have some examples now for you guys. Take some notes. You did that already. And so now let's try. You guys try this one. So find the area of this regular polygon. So this is a regular polygon. You guys give it a shot. See what you get. Okay? Where'd my thing go? Uh-oh. Oh, no. I'm looking for my pause button. Go back. Not that one. Not that one. That one. Okay? Give that a shot. Wait, is that the wrong problem? That's a different one than I had before. Sorry, wait. This one. I want you to try. Find the area. Okay. I better do my homework. I gotta pause my thing, so I'll be right. It's gonna get smaller for a second. Hold on. I gotta find this thing. 1/2 A, which is 14.5, times N, which is 8, times S, which is 12. Okay? Let's try the next one. Try the next one. Maybe it'll work now. Okay? Ready, set, go. Go. Try that one. Now you're going to go backwards and find the apothem. Give that one a shot. It's kind of important that you set up an algebraic equation. Otherwise, a lot of times you're going to get the right answer. So you know that A is equal to 1/2 A and S, or A and S divided by 2. Well, you know big A, which is 190. Sorry, I have to update my software somehow. 197 equals 1/2 A, you don't know, N you know is 12, S you know is, S is, oops, N is 12, S is 4.2, right? So you multiply by 2, right? So you get 384, divided by 12 and 4.2, right? 4.2 equals A, and when you do that, you get that that's about 7.8. 1, 2, we're going to try a couple more. Okay? Good? Questions? Okay, let's try the next one. Find the perimeter. Find the perimeter. Ready? I got 43.3. 43.6? Maybe you rounded a little bit too much or somewhere. Okay? So who got 43.3? Who got 43.6? Oh, let's see what happened there. And so I would use the formula. Area equals 1/2 AP, or A apothem times perimeter divided by 2, right? So first I'm going to multiply this by this. Maybe you're right. I think I did it wrong. Maybe not. So I got, this is 130.8, right? So if I take 2 times 130.8, that's 261.6, right? Equals A, which is 6 times big B, and I take that and divide, right? Divide both sides by 6. Is that right? That's right. So I get perimeter is 43.3. That's 43.6. 43.6. Yes? 43. How did I get 43.3? 2 times 130. Oh, I forgot the 0.8. I forgot the 0.8. That's what I did. Okay? So you were right, Cadence. 43.6 is the right answer. Okay, we're going to try one more challenging one. Okay? If you get this one right, you raise your hand and tell me the right answer to that. I'll give you a bonus point. This one's tricky. Okay? Give it a shot. On the area of the octagon, how do you do that?
So since it's 2 R's, you know that the apothem or something like that, that's
The
6.
apothem has got to be 6, right?
Yeah.
Very good.
And then S is 5.
And S is 5, so 1/2 A and S, right?
Yep.
Is going to be sorry about my thing, 1/2 6 times 8 times 5, right?
Yep.
Which makes how much?
120 units squared.
120, right? Let's say it's like centimeters squared. Then what do you do with that?
And then I find the area of the square.
Area of the square.
Yeah.
Okay. So that's the area of the octagon, right?
Mm-hmm.
And the area of the square is just what?
So that came out to 36. Divided that by one of the R's, which is 3. But then you know the side length, I knew that had to be 2R, because since it's a square, if you go to the since that's a right angle, that means that it has has to be twice it, like the side length has to be twice the radius.
Right.
Yeah.
So that's 6, right?
Yep. Yeah.
Okay. So you got the area. Then what do you do?
And then I subtracted 36 from 120.
Okay.
And I got 84. And then I realized that the shaded area, that part of it, was 3/8
Very
of
good.
the entire thing.
How
So
do you
like,
figure out that's 3/8?
Well, since there's the 8 sides of an octagon, the shaded part would be like 2 of those sides, and then plus 2 the halves, which would be 3 of those. So then I knew that was
Right. Okay. So like this is one side, right? And this is so he's got one side, 2 sides, right? And then he's got half of a side, and then he's got another half of a side. So altogether it adds up to 3/8. Yes. So he's got 3/8. So he has 3/8 basically of 84. So first he found if he shaded in this whole area, right, that would be 84, right? And then he took 3/8. I did a little bit differently. I figured out that this angle would have to be 135 degrees, right? So I said it was 135 3/60ths. My way is probably not as clean as yours. Of 120, right? That would be this part, right? Yes? And then I subtracted, this thing is what shape? What shape is that thing? It's a trapezoid. And then I subtracted the area of the trapezoid, okay? Which would work too. But there's lots of different ways to do it, but that's good thinking, okay? So that's it, okay? You guys could start on your homework. I'll put it up here in a second. The other thing I do have for you is